All right. Exercise number 3 is asking us to add a method called slope from origin, which returns the slope of the line joining the origin to the point calling the method. So for example, 0.40, or 0.410 rather, a point at 410, x equals 4, y equals 10, calling slope from origin will result in a value of 2.5. And that makes sense because if we look down at the formula down here for how to calculate slope of between 2 points, it is the y value of the second point minus the y value of the first point divided by the x value of the second point minus the x value of the first point. So in the case of our example up here, it is 0 minus 4, which of course is negative 4, and 0 minus 10, which is negative 10. You divide negative 4 by negative 10, and you get, negative 10 rather, by negative 4, and you get 2.5. Negative 4 goes into negative 10 twice, and then goes into it another half time. So negative cancel each other out, and you get 2.5. So that is as nice and easy, and that's all we need to implement, truly. However, there is one little hitch, and that is that dividing by 0 isn't allowed, because dividing by 0 will cause your Python code to result in an error. So this is true to how math works, how geometry works. When we have a point that has a 0 y value, we call that when we have a slope that has a 0 y value, so in our case a y value of 0 on our point minus 0 for the origin, is going to result in a 0 slope, that is a straight horizontal line going straight across. And that's fine. However, what's not fine is if we have a 0 value for our x's, because that means we're going to divide by 0, and that is a straight vertical line, and we say that that line in math has no slope, has not even a slope of 0, it has no slope. And so we want to return none when that happens. So we're going to need to use some sort of if statement that checks to see, is this going to cause x's to become 0? If so, return none. If not, actually do the slope calculation. So that's easy. We can take care of that nice and easy. So down here, I'm going to do this below our distance from origin, right down here. I'm going to define slope to origin. Is that right? I forget what it was called. Slope from origin. That's fine. All right, and it's going to take self. It's not going to take anything else because we don't need anything else. Origin is predefined as 0, 0. So what's going to cause our x's to be 0? What's going to cause a situation where we would accidentally divide by 0? Well, we know x2 is always going to be 0, so there's only one thing that will make our whole bottom value here, our whole numerator value here, evaluate to 0, and that's if x1 is also 0. So we know x2 is going to be 0 by definition. So if x1 is also 0, then that means that we're going to divide by 0. So we need to return none anytime the x value of our point is 0. So if self x equals 0, return none. And then we can just go on to the rest of our problem here. So otherwise, we need to do return. We could put this into a variable first. We could put it in a variable called slope and do our calculations, and then return slope. But that's not really necessary. We can just return the exact calculation down below here. And so it's going to be y2, which is 0, minus y1, so that evaluates to negative self y, divided by 0 minus x1, which evaluates into negative self x. And then we can get rid of the negatives because they're going to cancel each other out anyway. And so we just get self y divided by self x. And that's actually all we need to do here. So They have some tests in here down below, so we can just go ahead and run it this time. So let's go ahead and run our code, and we get all passes. Nice and easy. All right, very good. Here's another look at that very, very simple method that we just created there. Okay, here's our last one. We're going to want to add a method called move that will take two parameters. We're going to call them dx and dy. This method will cause the point that calls it to move in the x and y direction, the number of units given. And they helpfully tell us that we will need to change the values of the state of the point. Now remember that the state is the variables that we've created inside of the initialization function. So self x and self y are our state values. So we need to actually change those. So this isn't going to return anything. This method isn't going to return anything at all. It's going to be what we call a modifier method or a mutator method. All it's going to do is going to change something inside of the state of the class. So let's do exactly that. We're going to define move. It's going to take self because it has to. All of our methods take self. And then it's going to take a couple extra parameters. It's going to take dx, and it's going to take dy. And those are just going to be presumably ints that we will use to move our x and y around. And then, quite simply, since we don't need to return anything, all we need to do is change our x and then change our y. So self x plus equals dx and self y plus equals dy. That's all we need to do. That's the entirety of it. So let's go ahead and test it out. Let's create a point called P. We'll create it at, we'll just keep doing it at 3, 3. And then we want P to move 2 along the x-axis, but -5 along the y-axis. So P is going to move, and then we will print P out to see where P is at currently. So remember, it starts at 3, 3, and then moves and ends up 2 further along the x-axis. So it moves over to 5, and then goes down the y-axis by 5, leading it up at -2. 5, -2. That's it. That is the entirety of the move method. So that's just an example of how you can create a method that doesn't return anything, but instead changes the internal values of a class's state. So that's going to be especially useful in the chapter assignment for this chapter. The chapter assignment for this chapter is asking you to create a car class. So you're going to create your own car class, and if we look down below, it hasn't been created at all for us. So you're going to want to make sure that you're creating it with the same kind of formatting that we used up here, where we do class and then the name of the class, and then it's customary to leave yourself an extra line in between your class and your first method. So go ahead and do that. And then give yourself an initialization function that's going to fulfill this initialization method, this constructor method that they have down below here. Alright, so you're going to want to create a car class. You're going to want to give it a constructor that takes a parameter in addition to self that sets the initial gas level of the car, the same way that we took a parameter to set the initial x and y values of our point. And then you're going to want to create 2 additional methods. You're going to want to create an add gas method that takes as a parameter a single float and adds that to the current value of gas level. This is very similar to move, the way that we did move. And then you're going to want to build a fill up method, and that's going to set the car's gas level up to 13 by adding the amount of gas necessary to reach its level. So it's going to set the car's gas level to 13 if it's below 13. If it's above 13 to begin with, though, then it doesn't do anything to the gas level and just returns 0 instead. So If it's below 13, set it to 13 and return the number of units that you had to add to get to 13. If it's above 13, don't do anything and return 0. So that's all you need to do. And then it sounds a little bit more complicated than I just made it sound. But you really only need to do these 3 methods: init, add gas, and fill up. And a couple of these, init and add gas, are really simple. The real trick is the fill up method. So get going on it. Don't worry too much. It's actually pretty simple. And if you read back through the chapter and go back and look through the examples that we just did together here, I think that you'll find that it's going to work out nice and easy for you. Good luck.